Okay, hello everyone. I'm going to continue with a presentation in the same direction as the one presented last year in this same conference about La Draga, focusing on this one on surface correlation in the sequence of occupational floors at the very same settlement. La Draga is a Neolithic lacustrine settlement located at the shore of Lake Banyoles at the northeastern part of the Iberian Peninsula. Banyoles Lake is the second more extensive natural lake of glacial origin at the Iberian Peninsula. It's a lake of tectonic and karstic origin formed from the union of various dolines, as you can see here in the image. The waters that alimент the underground come from Alta Garota at 20 kilometers distance from the north. At the bottom of the lake, we have 13 subterranean sources that alimент the lake, providing 400 to 600 liters of water per second. 6 superficial fluvial sources were detected also at the western part of the lake, while canals are helping channeling out the exceeding water from the lake to a neighboring river. The 3 excavated sectors at La Draga represent only a small proportion of the total extension of the settlement, which is calculated around 10,000 square meters, with 1,500 of them being actually underwater. The 3 excavated sectors occupy only 1,000 square meters out of the total extension, and they were excavated since 1991 until nowadays. Those include Sector A, actually merged found in dry conditions. Sector B consisted by sectors B and D, situated in the water table. And last but not least, Sector C, completely underwater. The 3 sectors represent distinctive sedimentary environments with the subsequent characteristic inclination of the depositional units towards the lake and the conservation conditions of the archaeological material. You can see here Sector C, where we have everything conserved, instead of Sector A, for example, that is found in dry conditions. The first archaeological level in Sector A is preserved only at the level of post holes with associated wooden timber logs vertically positioned into the lake marl directly. Sector BD, found in phreatic conditions, has preserved all the wooden timber logs and the majority of organic material, while Sector C is found completely underwater and as a result has preserved every kind of organic material. The chronological time interval for the construction and occupation of the wooden platform seems to be around 5,320 to 4,980 BC, while the second archaeological level in Sector A has preserved travertine structures over the lake marl. At Sector B, a travertine kind of pavement with associated structures in it. While at Sector C, travertine blocks intentionally transported over the wood and timber logs are detected. Absolute chronological data locate this layer around 5,200 to 4,800 approximately, indicating this way no chronological interruption between the 2 archaeological levels. In order to properly define the occupational floor, we should first define the smallest unit of physical space differentiated by adjacent units based on its spatial properties. That would be a depositional event. So one or more depositional events can lead to an occupational floor, which thus is temporally defined as the formation at a specific moment in time and spatially defined as the lower contact of deposition on which action took place. An occupational floor thus can be a result of one or more activities and their final material products called occupational debris. So the objectives of this research are related in a chain way. First, to distinguish between the different depositional events, then to observe the effects of anthropogenic and geogenic processes on the occupational surfaces, and ultimately reconstruct the dynamics of formation and deformation process of the lacustrine settlement of La Draga. For this purpose, and once defined the occupational flows, we had to detect them on field. That was done at first microscopically during excavation, with stratigraphic observations and schematic representations in the form of plans and sections. And on the other side, sedimentary samples from microstratigraphical analysis were retrieved from various points of the settlement in order to clarify stratigraphic contexts and special geomorphological characteristics of the occupational floors. The micromorphological analysis was important in order to identify the nature of human activities taking place at the settlement, as well as information of use and reuse of space, but also the detection of periods of stasis or erosion, the so-called stratigraphic gaps not so easily detected in the naked eye. The results of micromorphological analysis also helped differentiate between anthropogenic and geogenic formation processes and show alongside with the macroscopical observations in the field, contributing to a depositional analysis of the site stratigraphy. This analysis will permit a higher fidelity, spatial correlation of the occupational floors. For this scope, a database was constructed, including the spatial information for each stratigraphic unit recorded in the field, stratigraphic information retrieved from profiles and plans, and on a later stage, the input of geomorphological characteristics. This information was represented in the form of sector, location, section, and stratigraphy sheets in Excel in order to introduce the numerical data of these variables. This information was then transformed into stratigraphical columns which represented this data. And from this point, we had to do all the connections in order to correlate the stratigraphy. One of the special variables is the depositional sequence of Draga with data retrieved from microscopic observations. Here we have a general example of that, where you can see, starting from the bottom and going upwards, we see the geological substrate of Lake Marl, that is the surface where the construction of wooden platforms is taking place. So the surface of Lake Marl is an occupational floor at the same time as well. Next, we can see the remains of use and final abandonment of this first occupational floor of wooden platforms. And after an abrupt transition, you can see a second occupational floor of different construction this time, including a travertine kind of pavement at sector BD and associated structures at sector A. The use, reuse, and possible appearance of other occupational floors is then visible here, while at the top we have a natural pit formation coinciding with the abandonment of the settlement. So here the geomorphological characteristics were then retrieved from all the three excavated sectors at La Draga, and here we have a symbolic representation of their position over the Lake Marl surface. Here you can see sector A at a more dry position, sector BD here, and sector C underwater. This would be the lake boundary. The interpolation method selected here to represent the depositional planes is kriging for its advantages to measure distances between all possible pairs of sample points and to subsequently use that information to model the spatial autocorrelation for the particular surface we're interpolating. It's most appropriate in our case as we have, as we know there is a spatially correlated distance in our data. The stratigraphic boreholes are then mapped and their interpolation via kriging begins. And in this case, we have an example of an interpolated cross-section in sector A. The generated sequence represents the depositional dynamics of sector A in possible stratigraphic contexts. First of all, we have the Lake Marl again, where the wooden post holes were inserted. Sorry, this one. Then on the top of that surface, the extension of travertine structures, this purple color, and then two layers correlated spatially, and those would coincide with the reuse and abandonment of the travertine structures. Last but not least, the layer of pit formation, the post-occupational phase of the settlement, and the superficial layer, which is archaeologically relevant. It's the result of modern agricultural and construction works from the 92 Olympics at Lake Banyoles. At a later stage of the process, we have proceeded to a stratigraphic correlation of occupational floors between sectors A and D, because they had a significant distance between them and we had different sedimentary environments. Once again, you have the Lake Marl here on the bottom of everything. And then on the top of that, you have the layer of use and abandonment of the wooden platforms. That would be this layer, the NA7. That would not be preserved at sector A due to dry conditions. And as a result, here you see the correlation stops. Later on, note the special autocorrelation of the second occupational floor. That would be the travertine pavement, once indicated with travertine, this one. And the structure E261, that would be the travertine structure of sector A. This part of travertine pavement of sector D and travertine structure sector A have been correlated this way. On the top of those, we have the abandonment deposits of travertine structures, NA4 and then A2002. And last but not least, the post-occupational layers of pit formation and modern soil inputs are the same as previously mentioned. Beginning with the reconstruction of the occupational surfaces, throughout the whole excavated area, elevation grids were created based on the calculated elevations of the top of each surface. Here you can see an example of the Lake Marl elevation grid, and its elevation map on the side. Here would be the lake boundary, and so you can see the clear difference of conditions of the three sectors. Sector A at a more elevated spot and dry conditions, Sector BD at a slight depression, which I will explain later, and Sector C underwater. Once the elevation grids for each surface are created, we proceeded to a sequence of those in order to detect possible stratigraphic contacts between them. As a result, the reconstruction of the occupational surfaces of La Draga includes, first of all, the Lake Merle surface with the introduction of wooden posts into the geological substrate. Alongside the surface, you can also see an isopac map, that would be that, which was created for its detectable stratigraphic unit. This includes the information of bottom and top elevations of each unit, and therefore we have the 3D representation of the surface. This would be the Lake Marl substrate and also the first occupation level. Next, we detect the occupational surface associated with the use and collapse of the wooden platforms, probably because of the ground subsidence created by the formation of a dough line, which is seen here and here as well in the isopac map. After the collapse of wooden platforms, the construction of travertine pavement in sector BD and travertine associated structures at sector A, and covering this second surface, we could have raised clay sediments of terrigenous origin mixed with dispersed travertine fragments, which are seen over sector D here, and over sector A, sediments covering the travertine associated structures as well are being detected. We can then pass to the post-occupational deposits, including the pit formation and the sediments of terrigenous inputs from the inland. You can see that provenance of the terrigenous input from the characteristic inclination of the sediment. Then we have a lacustrine input from possible lake transgression expanding further through the prehistoric settlement, this time the direction is on the other side, the direction of lacustrine input from the lake. And the exposure of a shoreline on later years after lake regression, as well as further transgression and lacustrine input into the settlement. Until, of course, everything was covered by the artificial input of soils for the 92 Olympics. So here we have the complete sequence of the occupational and post-occupational phases at La Draga, according to their geometrical representation as surfaces of contact and their subsequent correlation throughout all excavated sectors. Although it seems like there is the tridimensional representation of a surface, we don't have the volume between one surface and another, because this is affected depositionally by the surface that comes on top of it, as well as from the surface of which it lies on. It may include more than one depositional event and represents the interval of time accumulation of the sediments. Although not always thickness represents a greater depth, in order to explain the volume, we have proceeded into the introduction of additional data that would be absolute dating information, which we have from archaeological material dated at La Draga, special distribution of archaeological material which we would like to integrate into our final model, and more geomorphological attributes retrieved from micromorphological analysis. On the last presentation of this session, we have worked on this absolute dating information exactly in order to have the opportunity to integrate it into our stratigraphic model. But that will be presented at the end by my colleague Joan Barceló. And that will be it. Thank you very much. Some acknowledgements for the La Draga group. If it wasn't for them, we wouldn't have retrieved all the informations and necessary data for our research, as well as the PhD scholarship that I'm having at least for the next year, and all the projects that have helped me to develop my research. So thank you very much.